talk about transformations. So start with something we kind of know. Let's transform the absolute value function. Let's say negative absolute value of 2 times x minus 4 minus 5. Okay, so what we know here is we know that our basic function is absolute value of x, right? So the absolute value of x, our basic function, what you get in, we just make sure we strip off the negative sign, right? So the values here, we start out with, if we had negative 2, we get 2. Negative 1, negative 1, we get 1. 0, we get 0. 1, we still get 1. And 2, we get 2. So if we were to put that on our graph, it would look something like this, right? Come on, there you go, little marker. Okay. Right, because for at 1, 1, at 2, 2, at 3, 3, at negative 1, 1, at negative 2, 2, at negative 3, 3, so on and so forth. So now we want to transform to our new function f of x. So let's use a different color. Come on, let's start with blue. Okay, so we have 4 different transformations going on here. First one we've got going on here is we've got this inside. So remember, if it's inside the parentheses, we do opposite of what we think. So x minus 4, that means it's going to shift it to the right by 4. So we're going to add 4 to all of our x's. All right, so that's this one. Now, the next thing we're going to do, let's see if I can get a different color. Green. All right. Next thing we're going to do is we're going to stretch our function. So now we've got this 2. So now we're going to take our function and inside the parentheses, remember, I almost forgot. Inside the parentheses, you do opposite of what you wanted to do, right? So now we're going to multiply everything by 1/2. Okay, now we've taken care of the x values. The y values, let's start with red. So we've got 2 things going on with the y values. First thing we probably want to deal with is this negative sign, right? We want to take all of these values and we're going to reflect it across the x-axis. We do that by making everything negative. Then, do I have any more colors? I have yellow. Now let's see what yellow looks like. We've got 5. So now we've got to shift everything. After we've flipped it, everything is pointing down. Now we have to move everything down by 5. Kind of see the yellow, right? All right. So in the end, let's go to, what color do we want to use? I think blue is probably our best bet. Our new function, x f of x, is going to look like 4 minus 2 is 2. 2 divided by 2 is 1. 4 minus 1 is 3. 3 divided by 2 is 3 divided by 2. 4 plus 0 is 4 divided by 2 is 2. 4 plus 1 is 5. 5 divided by 2 is 5/2. 4 plus 2 is 6. 6 divided by 2 is 3. All right, on the left-hand side, we have negative 2 minus 5 is negative 7. Negative 1 minus 5 is negative 6. 0 minus 5 is negative 5. Negative 1 minus 5 is negative 6. And negative 2 minus 5 again is negative 7. So when we plot this guy over here on our graph, we're going to go to 1 and down to negative 7. We're going to go to 1 1/2 and down to negative 6. We're going to go to 2 and down to negative 5. 1, 2, 3, 4, 5. Okay. Okay, make sure I did that right. 1 and a half, 2 and a half, we're going to go back down to negative 6. And 3, we're going to go down to negative 7. Our new function looks like this. What you can see is it's been reflected, it's been shifted by 1. Well, it's been shifted, it's been reflected, it's been compressed, and it's been shifted down. So we've taken care of all of our different possibles. So this is the function that we kind of know. What happens if we start with something squirrely, something like this? So now we've got a made-up function. But we have points, right? So since we have our points are going to be at negative. This is our function, x, f of x. Negative 3, oh, I forgot the 5. Erase this, start out with first number. We have negative 5, 0, negative 3, 3, 0, 0, 2, negative 4, 4, 0, 6, 2, and 7, 0. So now let's say we want to, in red, we want to know g of x equals the negative 2 times f of x plus 2, oops, erase that, x plus 2 minus 3. So now we've got similar situation. Just because we don't know what this actual function is in terms of x's and y's, it doesn't mean we can't still transform it. So first thing, we've got x plus 2. X plus 2 means move to the left by 2. So we're going to subtract 2 from all of our x values. Now that's the only thing that really happens inside the parentheses. So everything else is going to have to do with the y values. So let's change colors. Green. So let's deal with this negative 2 on the outside. So we're going to multiply everything by negative 2. All right, now let's see, what have we got left? Ooh, I can use black now, black. So we've also got this minus 3. So now we're going to subtract, because remember, we're shifting down, because on the outside we use our intuition. Minus 3, minus 3. Now, I realize I didn't put my parentheses in here, and I don't want this to get too confusing. So let's put these parentheses back in here. So now we can figure out what our new function is going to look like. Graph our new function in, what do you want to use? Red. Let's use red. So our new function, we've got x and g of x. So negative 2 minus 5 is negative 7. 0 times negative 2 is still 0, minus 3. Negative 2 minus 3 is negative 5. 3 times negative 2 is negative 6. Negative 6 minus 3 is negative 9. Okay. Negative 2 plus 0 is negative 2. 0 times negative 2 is still 0, minus 3. Okay, what else have we got? Negative 2 plus 2. All right, there's our 0. And now we've got negative 4 times negative 2 is 8. 8 minus 3 is 5. We have 4 plus negative 2 is 2. We have 0 times negative 2 is 0, minus 3. We have negative 2 plus 6, which is 4. Negative 2 times 2 is negative 4, minus 3 is negative 7. Come on, 7. I'll make this 7 too. And finally, negative 2 plus 7 is 5. And again, we have a negative 3. So let's graph our new function. So we're going to go out to negative 7 and down 1 to negative 3. We're going to go to negative 5 and down. Did we do that right? Okay, now we're going to go down to 1, 2, 3, 4, 5, 6, 7, 8, 9. We were at negative 5, right? Okay, negative 5. Now we're at negative 2. We go down again to negative 3. When we're at 0, we are at 1, 2, 3, 4, 5. When we are at 2, we are back down again at negative 3. And when we are at 4, we are down at negative 7. And finally, when we are at 5, we are back here at negative 3. So now our function looks something like this. So we have reflected it, right? We've stretched it. And we've shifted it to the left, and we've shifted it down. I hope that makes sense. What we're going to do here, every time we see these rules, we're going to see whether if it's inside the parentheses, it affects the x values. If it's outside the parentheses, it affects the y values. I hope this helps.